Hello, my dear students. We will be discussing today the derivatives of implicit function. Now, what is implicit function? I would like to give an example that suppose we have a function like y equal to x plus 1. Then we can see that y can be expressed in terms of x, and moreover x can be expressed in terms of y, like x equal to y minus 1. Okay, in our life we come across many functions like this, that we can explicitly express y in terms of x and x in terms of y. Okay, these types of functions are called explicit functions. But there are some other functions also where we cannot express a variable like an x in terms of y directly. If we cannot express that y in terms of x or x in terms of y, then those types of functions are called implicit functions. Now, we have to differentiate the implicit functions. How to differentiate it? You see, from exercise 5.3, these are the questions. Find dy by dx in the following. The first question is 2x plus 3y equal to sin x. This function you can see, you may be able to express y in terms of x, but you cannot express x in terms of y, because if you bring this 2x to this side, and because you cannot take x common, because it is sin x, we cannot take common x so that we can express it in terms of y. So these are the examples of implicit functions. Now we have to differentiate these functions. Okay, you please see here, this is the question, 2x plus 3y equal to sin x. Very simple, given, I have written down here. Then differentiating both sides with respect to x. Okay, because we have to get dy by dx, so we have to differentiate with both sides with respect to x. So d by dx I have written here, left hand side, d by dx of the right hand side. These two functions we have to differentiate by using the algebra of differentiation. Differentiation of 2x is 2 and 3y is 3, then dy dx. Differentiation of sin x is cos x, then these two you bring this side, cos x minus 2, 3 dy by dx. So dy by dx equal to 3 will go down, it is cos x minus 2 by 3. Is not it very simple? Okay. Let's go to the second question. It is 2x plus 3y equal to sin y. The same process we have to apply here. 2x plus 3y equal to sin y. Differentiating both sides with respect to x, we get d by dx of left hand side, d by dx of sin y. It will be 2, it will be 3 d by dx. It will be d dx of sin y. If it is sin x, it is like this, sin x then cos x. Again, if we differentiate this x, then dx by dx, it will be cancelled, only we will get cos x. But it is y, so it will be like dy by dx. Okay, differentiation of sin y is cos y, and this y we have to differentiate by using the chain rule, as it is not x, so dy by dx. Now this term containing dy by dx and dy by dx you take to the same side, and other term you take to the other side. So 3 dy by dx minus cos of this equal to minus 2. Then you take common dy by dx. This part you will get. Then you divide minus 2 by this part. Okay. The minus I have multiplied here. Cos y will come as positive, and this 3 will be, oh sorry, it should be 3. I have done mistake here. It will be 3. Okay. I think you understood it, isn't it? Okay. I have done question number 6. Okay, because 3, 4, 5 are almost same. If I do the question number 6, then this will help you to do question number 5 and 4 as well. Okay, question number 6, x cube plus x square y plus xy square plus y cube equal to 81. Okay, just the same process. We have to differentiate both sides with respect to x. Okay, then okay, left hand side equal to right hand side. Then each and every term we will differentiate. It will be 3x square. It is in the product form, so uv that we have to apply, x square dy by dx plus y d by dx of x square. Then this is also in the product form, so x d dx of y square plus y square d dx of x plus this is y cube, you can consider it as x cube. Then it will be 3x square, so here it will be 3y square, but it is not x, so we have to differentiate this y along with this. by using the chain rule. So dy by dx, and the constant term, the differentiation is 0, so it will be 0. Now the parts will be like this: x square dy by dx, it will be differentiation of x square is 2x, so 2xy, it will be 2y, 2yx means 2xy, then again y is there, so dy by dx, it will be y square only because the dx of x is 1, and 3y square dy by dx equal to 0. Then you take common those parts having dy by dx as coefficients, so dy by dx is common, it will be x square plus 2xy plus 3y square this side, and the other parts you take to this side. Okay, then 3x square, 2xy, and y square will this side all will be minus, then I have taken minus as common, then this dy by dx will be like this. Okay, next it is question number 7. Question number 7, you see sin square y plus cos xy equal to pi. 8 is same as 7, so I have done only question number 7. Sin square y plus cos xy equal to same, we have to differentiate both sides with respect to x, and d by dx of this, d by dx of pi. Pi is constant, so this part will be 0, and this is d by dx of sin square y plus d by dx of cos xy. Okay, it is like sin y whole square, so that 2 will come in the front, it will be 2 sin y, then differentiate this sin y again. This is the application of chain rule. That's why I have taken the chain rule at first. You can go through the details in my previous video, which in which the chain rule was explained very nicely. Okay, the application part. Then this is cos xy means minus sin xy, but this part is not x, so we have to apply differentiate this xy part. Then it is 2 sin y, and ddx of sin y is cos y, but dy by dx will be there. Then plus into minus is minus sin xy. This part is again in the product form, so we have to apply the product rule. It is x dy by dx plus y ddx of x. ddx of x is 1, so only y equal to 0. Then 2 sin y cos y means sin 2y dy by dx. Then it is sin xy, and this x I have written here, I have opened the bracket, so that's why I have multiplied this, the x sin y xy dy dx, then minus into y is y sin xy equal to 0. Then you take common the coefficients of dy by dx part like this, then this part you bring this side, then you will get dy by dx equal to this. Okay, this is the way how to differentiate the implicit functions. Next question, I have done question number 9. It is given in sine inverse. Okay, that means we have to learn how to differentiate the inverse trigonometric function, derivatives of inverse trigonometric functions. Okay, same like we have done in the differentiation for implicit functions. We have to differentiate both sides, or we can convert it by using the property which we have got in inverse trigonometric functions. Okay, the properties we can apply so that the given function becomes easier, and then we can solve it directly. Okay, you see question number 9. Question number 9. Derivative of inverse trigonometric function, differentiate sine inverse of x. First, I have given the functions of differentiation of sine inverse x, cos inverse x, like that. Few differentiations I have shown here in this class. Okay, let y equal to this part sine inverse x, then we can write this x equal to sine y. Okay, then differentiate both sides with respect to y, because it is x in terms of y, so we'll differentiate both sides with respect to y, then this will become dx by dy. Okay, dx by dy, and this part will be d by dy of sine y. Okay, then dx by dy, d by dy of sine y is cos y. Okay, you can see here this y and y is there, so no need to write this part. Okay, if it is like, yes, this one you can see this x and this y, these two are not matching. Okay, x and y are not matching, then that it will be dy by dx part will come. Okay, if this and this are matching, then no need to write that part. Okay, you can think in that way also. So this y and y is matching, so no need to write this part again. That means the extension is not required. So dx by dy, and this part is sin y is cos y. Then you can reverse it. That means dy by dx you can write, and this part also will reverse. It is 1 by cos y. Then 1 by cos y means what? Cos y can be written as 1 minus sin square y. That is the identities of trigonometric functions. And 1 minus sin square y, this sin y is x square, so we can put here, it will be 1 minus x square. Okay, so dy by dx is equal to 1 by root over 1 minus x square. That means the differentiation of sin inverse x is 1 by root over 1 minus x square. Next I have differentiate this cot inverse x. Same process, we have taken y is equal to cot inverse x. Then you can write cot x equal to cot y. Then differentiate both sides with respect to y. Dx by dy equal to d by dy of cot y. dy by dy of cot y is minus cos x square y. Then you reverse it, you will get this. Then this cos x square y you can write as 1 plus cot square y, and then equal to minus 1 by, as this cot y means x, so it will be 1 plus x square. Okay, so in this way we can find the differentiation of cot inverse x. Okay, then you can see differentiate the function cosec inverse x. Same process I have taken here as y equal to cosec inverse x, then x will be equal to cosec y. Then differentiating both sides with respect to y, we get dx by dy equal to d by dy of cosec y. Then as it is, the dx of cosec x is minus cosec x cot x, so it will be minus cosec y cot y. Then minus, I have reversed it, so it will be dy by dx, it will be minus 1 by cosec y cot y, minus 1 by cosec y. This cot y can be written as root over cosec square y minus 1, and then minus 1 by cosec y means x, so it will be x root over x square minus 1. Okay, we can find out the differentiation of the other inverse trigonometric functions like this. Okay, you can see here, these are the differentiation of inverse trigonometric functions. The dx of sin inverse x is 1 by this, the dx of cosec inverse x is minus of this, tan inverse x is 1 plus x, 1 by x squared, cot inverse x is minus of 1 by 1 plus x squared. Okay, the dx of sec inverse x is 1 by x root over 1 minus x squared, then the dx of cosec inverse x is minus of x by root over 1 minus x squared. Okay, question number 9, the dx of sin inverse y equal to sin inverse of 2x by 1 plus x squared. So that we have to differentiate. This is the question, y equal to sin inverse of 2x by 1 plus x squared. This is given part. Now why I have written 2 tan inverse x. Okay, this you got in the properties of inverse trigonometric function. You can see here 2 tan inverse of x equal to sin inverse of this, and then cos inverse of this, and moreover tan inverse of this. So as a question is given in sin inverse of 2x by 1 plus x squared, that we can write in terms of tan inverse like this, 2 tan inverse of x. I have applied here. Okay, y equal to 2 tan inverse of x. Then differentiating both sides with respect to x, we get this part will be dy by dx, then this part is 2 will come outside, differentiation of tan inverse x. Differentiation of tan inverse x, just now we have got 1 by 1 plus x square, so we can write it as 2 by 1 plus x square. Very simple, isn't it? Okay, next question, this question number 10, y equal to tan inverse of 3x by minus x cube by 1 minus 3x square. Identity for tan function, which is tan 3 theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Okay, that we have to apply here. So I have taken x equal to tan theta, so that it will give us that identity. Then theta will be equal to tan inverse of x. So this y becomes tan inverse, then 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. And this is the identity which we can write as tan 3 theta. Then tan inverse and tan is there, so we will get only 3 theta. That means y equal to 3 theta means tan inverse x, so it is 3 tan inverse x. But we will differentiate both sides. dy by dx equal to 3 of differentiation of this part, then 3 by 1 plus x square. Okay, very simple. Next question number 12. Question number 11 I did not do. We have the formula cos inverse of this part is equal to 2 tan inverse of x. It is not sin inverse. Okay, but the question is this part is sine inverse, and in identity it is cos inverse. Okay, then we cannot write tan sine inverse of that part is equal to 2 tan inverse x, but can we convert it? Okay, now see, y equal to sine inverse of this, y equal to sine inverse of this I have written. Then this we can apply from where? Pi by 2 minus cos inverse of this I have written. But how? You can see here. Sine inverse of x plus cos inverse of x equal to pi by 2, isn't it? That means what? Sine inverse of x equal to pi by 2 minus cos inverse. That I have applied. Sine inverse of x equal to pi by 2 minus cos inverse of x. So sine inverse of this part equal to pi by 2 minus cos inverse of this. So pi by 2 minus, now we can write cos inverse of this part equal to 2 tan inverse x, because you see cos inverse of this part is equal to 2 tan inverse of x. So now I have written 2 tan inverse of x. Now it becomes very easier for us to differentiate. We will differentiate both sides. Then d by dx of this part, as it is constant, so it will be 0. Then 2, differentiation of this part is 1 by 1 plus x square. So it is minus 2 by 1 plus x square. Okay, I think you understood it. Next you see question number 14, y equal to sine inverse of this part. Okay, so can we make it more simpler, that we have got in inverse trigonometric function, to convert the function in the simplest form? How can we convert? It is under the square root. Okay, if we take x equal to sine theta, then it will be 1 minus sine square theta. So it will be cos square theta, then it will be cos theta. Okay, so sine x equal to sine theta will help us definitely. Even you can take x equal to cos theta also, because 1 minus cos square theta will give us sine square theta, which will become sine theta. Okay, so no problem. So we will go to either x equal to cos theta or x equal to sine theta. I have taken here it as sine theta. Then theta will be equal to sine inverse of x. Then this y will become sine inverse of 2 sine theta, then 1 minus sine square theta root over. Then this part will give us cos theta, and 2 sine theta cos theta means sine 2 theta. Sine inverse and sine theta is there, so it will be 2 theta. 2 theta means 2 sine inverse of x. We will differentiate both sides with respect to x. dy by dx equal to d by dx of this part. 2 will come outside, then differentiation of this part will give us 2 by root over 1 minus x square. In that way, we have done the differentiation for question number 14. Okay, question number 15, you see, 15 it is y equal to sec inverse of 1 by 2x square minus 1. We have to think for x. Okay, which one we are going to take? Sin theta, cos theta, tan theta, which one we are going to take? Which will give us simpler form for this function. Okay, so that we have to think of. Okay, so let us see. I have taken here it as x equal to cos theta, because I have shown here cos 2 theta equal to cos square theta minus sin square theta. Cos square theta minus sin square theta can be written as 1 minus cos square theta. Then this will give us 2 cos square theta minus 1. That means it looks like this, 2x square minus 1. So if I take x equal to cos theta, then this will give us this part, and ultimately it will give us this part, cos 2 theta. So sec inverse of 1 by 2 cos square theta minus 1 as x equal to cos theta already taken. So sec inverse of this 1 by cos 2 theta, because this part is equal to this part, and then 1 by cos 2 theta means sec 2 theta, and it will give us 2 theta, that means 2 cos inverse of x. Now we are in a position to differentiate it easily. dy by dx of this part, then 2 will go outside, then this part of differentiation is this, minus of this. So this is the answer of this question. Okay, thank you for today's class.